So we have two different cable companies providing cable plans, and we're trying to figure out when they kind of even out as far as the costs go. Now we'll kind of get to that. Let's start with setting up an equation. So if we're going to go with Uptown Cable, then that costs $120 for installation. We always want to think about this in terms of what is the constant cost that doesn't change based on any variable. 120 is just going to stay the same. It doesn't matter how many months we have the service, but for every month that we have it, it's going to be $25 per month. If we go with Downtown, then we can save some money on the installation, but we have to pay more per month. So this kind of shows the formula there. $60 for installation, $35 per month. And this per right here is going to be a clue for if it is a variable. So we just multiply this 35 by the number of months, and that'll give us the total cost for using Downtown Cable. So we can see, of course, where the numbers come from here as well. So the question is, let's see, where does it say it? We'll pay the same total amount. Essentially, when do these totals come out to be the same? And the way we can figure that out is saying that's whenever it costs the same for Uptown versus Downtown. So I have some equations for that. I have expressions. So if I replace Uptown with this expression right here and replace Downtown with this expression, I've set up an equation and I can solve for the number of months that it will be whenever these two costs are equal. So when I solve for M, it's going to tell me the number of months. All right, from here, it's straightforward algebra. So I'm going to subtract 25M from both sides. So that cancels out. I'm going to get 120 equals 60 plus 10M. I want to subtract the 60. And I get 60 equals 10M. And now whenever I divide by 10 on both sides, M equals 6. So it turns out after 6 months, it'll cost exactly the same amount. Anytime after that, then it looks like Downtown Cable is going to cost more. Okay. So if you want to double check that this is right, you could plug in 6 into both of these expressions right here. If you do, you're going to find both of them equal $270 at 6 months. All right, that is the process for going through that. If you didn't know what to do or if you made a mistake, anything along the way, you can just double check, even confirm that you did it correctly. So there you go. If you have any questions on it, please let me know. Otherwise, I'm going to keep moving forward. So rather than getting practice with the volume of pyramids and cones, I thought today, being a short day, it'd be better to throw in the volume of spheres. That's something we're going to learn anyway. But we learned a volume formula when did we learn that? On Friday. It was the area of the base times the height. Yesterday, we learned that for volumes of, this is for prisms and cylinders right here. For pyramids and cones, we learned that that's going to be area of the base times the height divided by 3. And those two formulas really aren't that difficult. You don't have to have them memorized. You do have a reference sheet for this, but they're not all in all that difficult. We're going to learn the volume of spheres today. This formula looks weirder, more complicated, whatever you want to think of it. But we're going to see, I want to reassure you from the beginning, that spheres are actually one of the easier things to solve for the volume. And we'll hopefully see why in just a little bit. But first of all, let's bring this up and let's look at what's going on in this diagram. Okay, so this is maybe not drawn to scale. This circle right here is supposed to have the same circumference around it, the sphere rather, should have the same circumference around it as these cones. It doesn't quite look like that. These cones look smaller, but let's just work with it. And these cones are set up so that the radius, I'm going to just draw it right here. The radius right here is the same as this radius, and the height of each cone is the same radius. And again, I just want to point out, you don't need to know why our formula is what it is. You just need to, I think it's good practice just for you to see where this comes from. And this is maybe not the best demonstration, but getting into the full sphere volume formula, it can be very complicated. So let's just kind of work with what we can. This is a good enough explanation. So I've got 4 cones here, and each cone has radius for the base, and that's the same radius for the height of the cone. We learned yesterday that the volume of a cone is area of the base times the height divided by 3. I don't particularly care what the numbers are, but I am going to substitute some things. Because this is a cone, the area of the base is going to be represented by pi r squared. The height of the cone is the radius also, so I'm going to put an r there, and I can divide that by 3. So that's going to give me pi r cubed divided by 3. Now we can see that there are 4 of these cones, equivalent cones. And what I'm about to do with this animation, pretend that this blue color is actual water that is going to be flowing down into this black pipe and then into the sphere. So that's the idea behind this. So I will animate it. You'll see the water flow in. And the combined volume of water from these 4 cones filled up that sphere perfectly. So when we do that, what we're saying is not only am I taking this one cone and putting it into the sphere, but I'm going to take 4 of them. So I'm going to have 4 times pi r cubed over 3. So that gives us our final formula. We can write it a couple different ways. I could write it as 4 times pi times the radius cubed over 3. And that's the volume of a sphere. Or it could be written this way, 4/3 pi r cubed. Again, this formula is given to you on your reference sheet. You will have access to it. You don't have to have that memorized. It looks complicated compared to the other ones. And it certainly kind of comes out of left field as to why this is the formula. But let me now reassure you, this is actually one of the easier things to solve. And let's do a practice problem to explain why. Get back to our main presentation here. Okay, so now we're looking at our first sphere. With the other solids that we looked at, prisms and pyramids, cones and cylinders, we need to have at least 2 dimensions given. And sometimes we need 3 dimensions given. And sometimes they give us extra information, which requires a preliminary calculation, and it can get kind of messy. So even though the volume formula for a prism is just area of the base times the height, that doesn't mean it's going to be an easy problem. The good thing about this formula, volume equals 4/3 times pi r cubed, is that we only need to know 1 dimension. We just need to know the radius. If we know that, we can calculate it. So I'll kind of walk through, because the tricky part with this is going to be how we plug it into the calculator. So it's going to be 4/3 times pi times 2.2, not squared, see? It's going to be 2.2 cubed. You can plug this into your calculator all at once. You are more likely to make a mistake if you do that, because if you don't type it in exactly the right way, then your calculator will read it as a different problem and give you the wrong answer. So what I might suggest you do is do this 1 step at a time. So you could do your 2.2 cubed. And the way that you cube something on your calculator, in case you haven't done that before, I had a calculator over here. I lost it, so. You will see on your calculator, you've got your squared button right here. And just above it is this kind of arrow pointing up, and that means raised to a power. So let me show you what that looks like on my calculator. If I do 2.2 raised, so 2.2 raised now to the 3rd power, is hit 3. So that's 2.2 cubed. There is no cubed button. So that raise button can raise you to any power. You could even do squared that way. If you want to do 2.2 squared, you can just do raised to the second power, but it's not necessary. So we can do that and we get our answer, or at least that part, 10.648. So now I have 4/3 times pi times 10.648. And maybe at this point you could do your 4/3 times pi times 10.648 if you feel comfortable trying that out. That's not a problem. And in your calculator, you actually just do 4 divided by 3 times pi times 10.648. That will work. And it'll look like that. But maybe you decide you just want to do 10.648 times pi. So if I do that, we'll get 10.648. I have the pi button right here, and I actually don't even have to put multiply. I can just do that, and it'll still give me my answer, which is 33.4517. Okay, I'm keeping a lot of extra digits right now. In the end, I'm going to round to the tenths, but I want to keep these digits for now. So at this point, I can plug this into my calculator and it might look like this. Oops, don't want to undo. So I could just have 4 divided by 3 times 10.684. And when I do that, I get 44.6023, which when we round it, we get our 44.6 centimeters cubed. So this is an easy problem and it's a difficult problem because if we don't write down or if we don't plug things into our calculator correctly, we could get the wrong answer. But we don't have to search and search for all the dimensions that we need. We only need one. So is everyone able to get 44.6? Okay. So I'm not going to go through every step of the calculation again, though if you are struggling with it and you're not getting the right answer, then we can certainly kind of figure out why that's not working. So what I will do is I'm going to give you 2 more practice problems. And with this one, let's just start by doing this. Volume equals, and can someone fill in the rest of our volume formula for this particular problem? So we did get 3 answers that all agreed with each other, and that's good. I will say, I bet, well, maybe no one made a mistake on this, but I wouldn't be surprised if someone did make a mistake, because here's a common mistake. And this, I saw this earlier today. Sometimes you're working fast, and it's not that you don't know what you're doing, but sometimes you accidentally put squared right there. And so if you got this answer, 1,847.3, so if that's what you got, it's because you squared your radius rather than cubed it. And there's even someone who was working so fast. Again, I don't think it's that you don't know what you're doing. It's just that you're working too fast. Some people forget to square or cube it altogether. So they just do 4/3 times pi times a radius. And in that case, if you got 87 point, well, it'd be basically 88.0. So if you get 88.0, then that might be because you forgot to cube your radius. So those are not uncommon mistakes. And that's about the only thing you need to be on the lookout for. And so let's just do this last one. So I'm feeling good with this. Let me clear all the writing. And I don't even want you guys to write down the volume formula on the screen. You can on your own paper, but don't write it on the screen. I'm just going to leave this blank. And when you're done, anywhere on the screen, you can write down whatever answer you get to this volume. All right, 904.8. That is the same answer I was able to get. Just to quickly show, that's going to be 4/3 times pi times our radius here is 6. So that'd be 6 cubed. And if you got 150.8 or 25.1, then that meant you didn't do this part correct, the raising it to the power. So if you were not able to get these answers, then make sure you stick around and get some help with that. If you were getting it right, then you basically have the spheres down. It's a weirder formula. It's a little bit more difficult on the calculator to make sure you plug it in right. But besides that, it is a pretty simple calculation to do, a pretty simple problem to have. So there we are. Hopefully everyone's feeling good with that. Your homework tonight is just going to be a lot more of the same. I can't remember how many you have, maybe like 8 or so spheres that you need to do tonight for homework. And you can get that done right now. There is an answer key, so you can check your work along the way to make sure you're not making a mistake. And besides that, if you have questions on this or anything else, stick around. Otherwise, you can have yourself a wonderful day, and I will see you tomorrow.